Okay, so we just completed this, right?
Yep.
Okay, so how are you guys feeling about isotopes? You feeling pretty confident?
Yeah, good.
I feel
Okay.
much better.
Okay, good. That's where we want you guys to be. Okay, so now we go back to Dalton's theory, right? So what was Dalton's theory? Do you guys remember his theorems? I know it's early morning. Your coffee hasn't kicked in yet. You're just coming off the weekend. Do you remember these theorems? Yes, no, maybe?
Yeah.
Yes.
Okay, excellent. So I should also tell you, so you guys have a test. Your test will open up this Friday. And you have until Monday at 11:59 to complete the test.
11:59 in the morning or at night?
At night.
Okay.
On Monday. Okay?
Okay.
Are we able to use notes on the test or?
No, you cannot use notes.
Okay.
You can use your periodic table. You're able to
Okay.
use your conversion table. You're able to use anything that's in that resource section.
Okay.
Okay? You can use that on
Is
the
it
test.
able? Are we allowed to have it printed out, or does it need to be like? How
Yeah.
does that work?
Yeah, you can have it printed out.
Okay.
Yeah. I strongly recommend that you have it printed out.
Okay.
Okay? So,
All right.
let's see. Cole, are you there?
Yeah, I'm here, Dr. Henry.
I'm going to make you, because there are going to be people that are going to lose connection, and I'll forget about them, and they'll be waiting in the waiting room for hours.
Okay, sounds good.
So I'm going to make you a co-host so you can let people in.
Yep.
Okay, so we're talking about Dalton's laws, right? So which one of Dalton's theories, not laws, Dalton's theories, which one of Dalton's theories were incorrect based upon what we know now?
Three of the four?
3 of the 4? So 3 of the 4 were incorrect? Can you point them out?
No.
And tell me
no.
why they were incorrect.
What was that? Sorry.
You said 3 of the 4 were incorrect, right? So, okay, can you tell me why those 3 of the 4 were incorrect? Which 3 of the 4?
The first one is wrong because not all atoms of a given element are identical. Like sometimes there's more neutrons.
Okay.
And then the bottom left one, any or all atoms, it says including mass, it would be the same, and that's not. Like if there's a different amount of neutrons, they have a different mass. And then the bottom right is that doesn't make sense. The in a ratio of small whole numbers, like they can combine however. And then the top right, I mean, if it's the simplest unit, yeah, they can't be destroyed or created, right? I think.
Okay. So we know that an atom can be destroyed or created. Right? We know that it is indivisible because that was one that was listed, although that's not shown up here, meaning that it can be broken down into electrons, protons,
Doorknob. I'll be right back.
And then we also know you're actually incorrect about this one. This one is actually
Be right back.
Okay.
Okay, Lauren.
So we know that atoms can be combined in small whole number ratios to form compounds, right? CO2, right? 1 carbon, 2 oxygens, or carbon monoxide, 1 carbon, 1 oxygen, right? So that one holds true. So you're right on 2 of them, but you're incorrect on 1.
Okay, gotcha. Yeah, for some reason when I read it, I thought it meant like the mass number had to be whole. I don't know.
No. Okay. Piece of cake. So okay, so we've talked about the atomic mass, and we've talked about the atomic mass being, which I'm going to share with you now. It's based on carbon-12. So carbon-12 was used as our reference because it had exactly 6 protons and 6 neutrons, and it weighed 12. And so we use that as our standard for all of the elements on the periodic table, right? So that was going to be used as the reference for all the elements on the periodic table. So we know that, and I've told you this, and I'll reinforce it, that the mass of the atomic mass on the periodic table is just the sum of the average of all of the ions, all of the isotopes of that given element. So for instance, there are 3 isotopes of neon. There's neon 20, there's neon 21, and there's neon 22. This tells us the relative abundance of each of those isotopes. Okay, so give or take, we're going to say neon 20 is going to be about 90%. We'll say 95%. We have, so we have neon 21. I'm going to say that's approximately what, 5%? Yeah, I guess it can't be 5.
Yeah, looks like it could.
Well, if this is 95,
But if you're going by 20, oh, yeah.
So that's going to be about 90. This one, I'm going to say is probably like maybe 2 or 3%. And then we're going to say the rest is 22. Okay, roughly. Okay, so this is the relative abundance of each of the different isotopes. So in this case, we're talking about neon. (22). In this case, we're talking about neon 21. And in this case, we're talking about neon 20. Okay, so the way that we would sit there and get the number that we see on our periodic table would be the mass multiplied by the abundance, the fraction part of the abundance. So
I talked to another person and their work had the same thing.
you say the mass is 20, 20 times 0.9.
It started as a little tiny pink thing and it just keeps getting bigger.
Plus
Watching him every morning come out with big
21
I couldn't hardly see.
times 0.03.
I think for him the easiest is to lay him down.
Plus 22. And if I write over here, you guys, can you guys see it on your screens?
That's what I mean.
Yeah.
Let's do it that way.
So 22 times 0.07. So if we do that math, we should get approximately what we see on our periodic table. It may be a little bit off because we may be off by how we read our graph, but should be close enough. So this is 18.
Good sign. Yep. If you tranquilize a horse, you gotta watch where you're standing because they stumble around and they're a lot bigger than what we are. Tell him you didn't get that much. Just lay down.
This is 0.63 plus
No, lay down. Lay down. Good boy. Bring the instrument, Charles. Got it? Watch out. It looks like it's affected to the eyeball, Julie. Don't pay the attention.
Okay, so our mass is going to be approximately 20.07 AMU. Let's see how far we off.
And he needs more than equalize. It's not to keep him quiet. This horse actually that if we calculate 1,500.
Is somebody doing laundry?
Even when you tranquilize a horse, it's sedated, the horse can still see, and so it sees you.
So let's go to P table.
It doesn't like it. They still look.
Can someone mute their TV about horses?
Yes, I will. Done.
Thank you.
Okay, so for neon, we have 20.18. So we weren't too far off with our guesstimation. We got 20.17, right? So that's giving us the average if we take all of the isotopes that occur naturally, okay? So do you guys understand how to use these isotopes to sit there and calculate the atomic mass on the periodic table?
Can we do another example?
We sure can. I have one right coming up. Okay. Okay, so let's see. It says the natural distribution of isotopes of boron is, let's see, is 19.9%, and that's boron 10 at a mass of 10.0129370 units and 80.1% boron 11 at 11.0093055 units. Calculate the atomic mass of boron. Okay, so what are we going to do? I apologize for the construction. I can't control it. Okay, so where are we going to start? Not all you guys yell at me at once. Let's see, who am I going to pick on? Let's go with Roman. Are you there, Roman?
Yeah.
Okay, so Roman, where are we going to start?
Oh, with the
Where am I given?
percentage?
What was that?
With the percentage?
Okay, so we have the percentage. So we have 19.9%. What is the decimal version of 19.9%? Or the fractional version?
0.199.
Okay, you said 0.199. Okay, and that's going to be multiplied by which mass?
10.
Okay, so it's going to be multiplied by this given mass, which is going to be 10.0129370 units. Okay, and then
And then you add the 80.1.
okay,
It'd be 0.801. Plus the 11.0.
multiplied by the 11. Yep.
Oh, yeah.
Okay. So what do we get? So I've got 1.99 times 10.0129370. Okay. How many sig figs should I have for this number right here?
3.
3. Okay. So let's just go ahead and put our sig figs. 1.99 plus 0.011 times 11.0093055. So how many for the sig figs for this multiplication here?
3.
3.
4.
3 or 4?
3.
Okay. So we add them together. Okay, piece of cake.
Yeah.
Okay. Our second. Yep.
11/5 not matter? Like those little numbers, the 10/5, 11/5, those don't matter in this equation?
What do you mean by they don't matter?
I mean, like, you don't do anything with them.
So that 10/5 does not mean 10/5. So if you go back over the notes, this is just telling me the mass number was 10, which we got right here. This is the exact mass number. So this here, I should say, not the exact mass number. This is the exact atomic mass of this isotope. Mass number is a rough estimate, right? It's just based on the number of neutrons and the number of protons. Now, the weight of a neutron is actually 1.0070079. The weight of a proton is 1.00841, something along those lines, right? So can we just estimate 1, right? Because it's going to be essentially 1. Here, this actually, they do the calculations exactly. The exact weight of a proton and the exact weight of a neutron. And that's what they're giving us here. So remember, this number here is our mass number, and this here is just our atomic number. So we've already taken that into consideration. That just tells me my mass number and my atomic number. Those are not fractions, and you don't want to make that mistake, okay? You want to be sure of what things are. Mass number, atomic number. And you'll also see it written just with just the mass number, okay? So the atomic number you should always know by looking at the periodic table. That's always given to you on the periodic table. The atomic number defines that element. Okay?
Okay.
So it's not like you're throwing it out the window. You are using it, but really you have the exact number, so you don't have to use the estimate in this case.
Oh, so if the exact number wasn't there, that's the number we would use.
That is correct, because that is the mass number, yes.
Okay.
Yeah. And if you actually do the math, it'll turn out to be approximately the same thing. Okay? But good question. Because I know there was at least 5 other people that were thinking the same thing, but too scared to ask. Okay, second question. Naturally occurring lithium is composed of two isotopes, 7.59% of 6.01512224 and 92.41% of 7.0160041 units. Whew, that's a lot of words. Okay, determine the atomic mass of lithium. Okay, who's going to be my volunteer? Or do I have to volunteer somebody again?
I'll give it a shot.
You'll give it a shot? Excellent. Do you want to write on my board?
I don't even know how to do that, honestly.
Come on, you've been in this class for how long and you don't know how to do that yet? Okay.
I'll do it if I can write. I don't know how to write though.
Okay, so let me tell you guys how to write. Okay, so if you go up to the top, you'll see a green banner that says viewing Kenneth Henry screen. Go up a little bit over, there'll either be 3 dots or it'll say options. Click that option and then it'll say annotate. Then what's going to pop up is going to be a menu. It's going to say mouse, text, draw, stamp, spotlight, erase. Do you see that?
Yes.
Okay, so hit the one that says draw. Hit the one that says draw. There'll be a squiggly line. Use that, and you can draw on my screen.
Okay, mine just straight up doesn't have that. The only 2 options are original size and enter full screen.
Okay, so you must have a Chromebook.
Yes, I do.
Okay, so that explains it. So then you're going to have to dictate to me. Oh, but yes,
sorry.
Go ahead. You can help each other. So go ahead.
All right.
Keep going. You're doing a good job, Z.
Supposed to be a 0. I think I'm gonna run out of space, but can I just, whatever, I'll just do it.
You can also type it.
Oh, that'd be a lot better.
Yeah, so there's also text.
Okay.
So if you hit text, you can type it in. That'll probably give you a little more room to work.
So I gotta erase all that, right?
I can do it for you. It's done.
Thank you.
So while we're waiting for him to get oriented real quick, there won't be any labs this week. Okay, so no labs this week for you guys. You guys take this opportunity to study for your test. Okay? Take this opportunity to complete the next homework assignment because that's going to be on your test. Chapter 4.
Dr. Henry, there's some 2 questions in chapter 4 that I still haven't done, but I've been reading the book, but you haven't went over it. But in the book I read it, but I still don't get it.
Okay, so I'm sure we'll go over it, but what we can do is after we're done today, you stay a little bit, we can go over those problems.
Okay.
But I'll have to charge you $12 for it. But we have to do it quick though, because I have another class right after your class. I keep forgetting.
I was gonna ask you, if Friday are you gonna give your homework, or was it just this Monday?
It was just this Monday. So I did it last Friday because we had that holiday. And so I always want to try to at least meet with you guys once a week, give you the opportunity to come and bother me for at least once a week. Who said, oh, great? Don't cry.
I did.
So what we can do is we can set up the time potentially on Thursday that, no, actually we can't. Let's see. Yeah, actually we can. We'll set up a time that we would normally have, that the time that you guys would normally have a lab. We will have basically a, not a review session, but a question and answer session on Thursday for about an hour to 2 hours.
Early in the morning or in the afternoon?
I think we will do the morning, although I'm
Okay.
considering, I have to think about it. The morning more
Okay.
likely.
Okay.
Sorry, guys.
Aren't you supposed to multiply those numbers
Yeah,
by
I'm trying to
each?
undo this now, but
Let me see if I can help you out a little bit.
yeah.
Let's see, because
Go to
I have a little more
backspace or
power than
something.
you do. So
Okay.
we
Hey,
need
would
to
it
multiply
be
this by what?
0.759?
Right. No, 0.075.
0.0759, like
Right.
this?
Oh, okay.
Is
I
that
don't know
right?
why I didn't put a 0 there.
Yes.
And then this one, we need to multiply by what?
Then that one will be 0.9241 times 7.0160041.
I don't understand
What
why
don't you understand?
we did 0.199 for 19% and 7.5%. We're not doing the same thing. We're doing 0.0.
Yeah, because if you
Because
divide that by 100, what do you get?
Okay, got you.
Because anytime you're using percentage, it's based upon 100%.
100% right.
And then that'll give us 241 times 7.0160041. So 6.4834893.
You said you're gonna have to repeat that and go slower.
Okay. So for the first one, the product is going to be 0.4565. You want the
Okay.
whole thing, or are we doing the sig fig thing?
Oops. So say it again.
So for the first multiplication problem, the product
Yeah.
would be 0.4565.
You said 4.4.
Yeah, 0.4.
So 0.4.
Right.
565. Okay, how many sig figs?
Okay.
How many sig figs will we have for that first
Oh,
multiplication?
well,
3, 4.
I forgot what it's going to be. Oh, it's going to be based on, okay. For the first part, then it's going to be 3.
Okay. So the answer should be,
So it would be based on the 5, and after the 5 is a 4, so it's going to go to 0. So 4 or 5.
it's going to go to 0. So you're telling me, so you did that math and you said that there's a 5 and then there's a 4 after this.
Right.
So we're taking this number here, which is a 5.
Right.
So are we going to round up?
No, I'm sorry.
What was that?
Well, when there's a number following the 5, it automatically goes up, right? So
Okay.
457.
Okay.
0.457.
Okay. Plus.
Oh,
did I erase? I erased the other part. Sorry. There we go. 7. Okay, there we go. Okay, and this one here?
We got 4. Oh, so our number was 6.4834.
Okay, so 6.4834. So
Right.
you said there's 4 sig figs.
Right.
So I'm going to use.
Because the 4 is under 5, it's just going to drop off, and we
Okay.
leave it, right?
That's right.
0.6483.
That is correct.
Okay. And then 6.483 plus 0.457 is going to give us 6.94.
Okay, piece of cake.
Yeah.
Okay. Questions? Concerns?
I thought every time when we do sig fids, we don't round up unless it's a higher number. Oh, wait. Never mind. Never mind.
Oh, shouldn't there be another number here? Because there's, if you add these together,
No.
although, shouldn't there be a 0?
I'm so confused.
Yeah, no, maybe?
No.
You sure?
Well, the
So-
0 won't matter, right? Because it's not going to make a difference.
Well, it is going to make a difference because you're telling me that you're sure about that 0. Are you sure about that
If
0?
I don't have the 0, then I'm sure about the number, but adding the 0 makes it uncertain?
No, so, no, adding the 0 tells me you're sure about that point right there, that
Okay.
is actually a 0, right? Because it's after that decimal point. If we didn't add the number, we're saying we're unsure about that number right there.
Okay.
Right? But when you do the addition, you have 7 and a 3. That's definitely going to be a 0, right?
Right.
And if you line these up on top of each other and we draw the columns, they will both be outside of here. So it would be a relevant 0.
Okay. So 6.94 would be wrong if we didn't include the 0? Just to
You
be
would
sure?
get deducted a point, yes.
Okay.
You get most of the points, but you get deducted 1 point.
Okay.
And Cole will tell you about how those little points add up.
Yeah, yes, they do. They'll cost you a A or something.
Okay. Okay. Next. So this is just a table of just showing you some of the natural occurring isotopes and their percentages. Okay. So you can use this table if you happen to get this table on an exam or something along those lines. You should be able to sit there and do the same calculations without a problem. You just have to figure out the isotope, the element that we're looking at, and make sure you got the isotopes for that. Okay. So you guys see that piece of cake?
Yeah, where's this table located at?
This table is located in my slide presentation.
So I can make a copy of it?
Yeah. It's available to you on modules. You guys need to learn to go and just click stuff on modules. Right?
Okay.
If you break it, don't worry about it. They pay me to try to fix that part of it, right? Or I try to get somebody else to do it, one or the other. So just
Okay.
go and click to figure out things. Don't do everything, you just click, to see what's there. You guys have a lot of material that's there for you to help you. Take advantage of it. Okay? So I want you guys to pay attention to sulfur because the next question deals with sulfur. Okay, you ready? You got sulfur down?
No. There we go.
Okay, now you ready? Okay, so we're going to use the data from the table to calculate the atomic mass of sulfur. So how are we going to go about this?
We're gonna go for the first one, 0.094 0.9493 times 31.972.07069. Is that right?
No, let's go. I'm gonna have to take a look back. Come on.
I
So,
went by the first one.
the very first one is
Right.
94.93%, right?
Right.
And then we're going to be multiplying it by this.
The 31, right?
Yep.
That's what I said. Maybe I said the percentage wrong in
Yep.
decimal form.
Okay, so let's fix that real quick.
Oh, I did get it right. I'll be right back. I got a kid working in my yard.
So 0.9493, right? Because remember, we're dividing it by 100. Okay, so then we're going to multiply by that first number, which is, should I type it? Would it be better for me to type it, or would it be better for me to write it?
Type it.
Type it.
Oh, and so my handwriting. I see how it is. Okay, and we're multiplying that by 31.972.07069. Okay, so the next percentage is
0.76. Times 32.971. 45850.
45850.
Yes.
Okay. Plus
0.0429.
Times.
plus, got to go to the other line. Run out of room.
0.0002. Times 35.967.
35.967.
967. 08088. One more 8.
One more 8. Sorry. Okay.
The last one.
Okay, so what do we get? Let's plug in those numbers. Okay, how many sig figs are we going to get for that very first number?
4.
We're going to have 4 sig figs. What did you guys get? I'll tell you what I got. If it lets me write. 30.3510866. So that answer should be what if it was 4 sig figs?
30, 35.
30, 35.
Okay.
I got it. Yes.
Okay, the next number.
It's gonna be 2 sig figs.
Okay, 2 sig figs. So then that should be,
So it'd be
see, this is what I got.
0.25.
Okay. The next number.
It would be 3 sig figs.
Okay.
So it should be 1.46.
And then the last.
It would be 1 sig fig. So 0.007.
Okay.
$32.067.
Okay, so you get 32.067.
That's what I got. Am I coming across too loud?
Well, I can't hardly tell because I'm getting vibrations. So
Okay.
how many sig figs should I have?
5.
5?
Wait. Yeah.
Are you sure?
No, I'm not actually.
Okay, so where would I draw my lines?
Okay. Right down the middle.
Right down the middle?
Wait, right here, right. Oh, you can't see where I'm at. At the 5s.
Right here?
Yeah, I think so.
Okay.
So 6 becomes a 1. So it's 32.1. So maybe 3.
So what's going to be my final answer, you said? What am I going to use to round?
32.1.
32.1?
I believe so.
Do you guys agree with her? Anybody disagree with her?
No.
No? You all agree?
Yes.
Well.
The answer is incorrect.
Oh.
32.07.
Oh.
32.07. That is correct.
Yeah.
Because
Oh.
we use that line, remember, the number after the line is what we use to determine if we're going to round up.
Okay. Good call. Bad coloring. So I had the line right though, right?
Yep, you had the line right, but you didn't
So now
use
I
it.
just need to realize what number I need to round up.
Okay, and the units would be units, or AMU, atomic units.
Okay.
Okay, piece of cake? Not too hard?
Getting there, yeah.
No.
Good, good, good. Okay, ready to move on?
Yep.
Yeah.
Here. Okay, so you guys know that Z is going to stand for atomic number, so you guys keep that in mind. You want to definitely keep that in mind, because you're going to see questions that will use Z, and you should know that that means the atomic number. Okay, so let's see your skills. You have your periodic table available?
Somebody.
Yes.
Okay, so I'm going to say the name of the chemical. I want you to give me the atomic number. Okay, the next thing I want you to do is tell me where it's located, because we have organization to our periodic table. Our periodic table is organized in a fashion where we have up top, we have what we call the group number. So if you guys look up here, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. So those are called your groups, right? And then on the sides, you'll have numbers as well on your periodic table, although it doesn't show it on this one. Those are called periods. So 1, 2, 3, 4, 5, 6, 7, 8, 9, or 7 actually is the only one that we have. Those are your periods. So in the old days, right, before we started really understanding some of the chemicals that were on the periodic table, we would only work with the main group. The main group are the ones that say 1A, 2A, 3A, 4A, 5A, 6A, 7A, 8A. We would just ignore all of the elements that were in the middle, because at that time we didn't have a clear understanding. So some of the older periodic tables will have the groups listed as 1A, 2A, 3A, but the newer periodic tables will have it listed as 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, because we don't want to ignore them. We're starting to figure those things out. Okay, you guys got that?
Yeah.
Yes.
Okay, good. So I'm going to test you out. I'm going to pull up my P table, because I like P table better than this periodic table. And then I'm going to say it. And what I want you guys to do is give me the atomic number, the period, and the group. Okay? You guys got that? You know what you're giving me?
The atomic number, the period, and the group.
Excellent. Okay, bismuth.
Bismuth.
Oh, one other thing. Also tell me what type of element is it? Is it a metal? Is it, and if you get specific, if you tell me a transitional metal, post-transitional metal. Okay?
Bismuth is 83 for atomic number.
It's 35.
No, he is correct. Bismuth is 83
Where's it
for the
at?
atomic number.
It's
83.
on, it's
Oh,
in
there
the
it
group
is.
15.
I
And
was
it's,
looking at Bouzme.
and it's in group 15.
15. And
Okay,
that's the, it looks like pryctogens.
okay.
And I forgot what
Oh,
else did you need? Oh, is it a metal or
The
not?
period?
The period is
6.
6.
That is correct. And what type of element? I mean, you told me it was a pictogen, but tell me what type of element is it? Is it a post-transitional metal? Is it a transitional metal?
You know, my periodic table is not color coded. Let me. Oh, you know what? You have yours up. So it's gonna be
Other.
It's metalloid? No.
Nope.
Other
Sorry,
metals.
Post,
post-transition
yes.
metal?
It is
Yeah,
a post-transitional metal. That's right, post-transition metal. Okay,
Where does
so
it say
let's
that
see.
at?
Let's do zirconium.
On the screen, if you look, it's color coded, and so like between 6 and 12, there's that little key, and then you can just come up with that.
See right
Okay.
here?
Okay, thank you.
Yeah.
Zirconium.
The zirconium, ZIR.
Is it ZIR? That's the symbol?
No, ZR. If we're, I was just making sure there's not a
CR40, right?
Okay.
zirconium,
Yes.
zirconium 40. ZR.
And it's in period 5, group in between 4 and 5.
Group 4.
Yeah,
Period
group
5.
4, period 5.
Okay.
It's transition metals.
Okay. Piece of cake?
Is that right?
That is correct.
Yay.
Okay. What about selenium?
Polonium?
Selenium, not polonium. Selenium.
Selenium.
34.
Yep,
Group 16.
period 4.
Period 4.
Okay.
And it is green, so it's going to be reactive nonmetals.
Okay. What about Krypton? Not the TV show.
It's really a thing, huh?
36, it's group 18, and it's period 4.
Okay. And what is it?
It's a reactive nonmetal.
Are you sure?
Noble gases.
Yeah, oh my
Okay. Let's see. Uranium. You can't give me the group, really. You can give me the period, though.
The period is 7.
Okay.
92.
92.
Okay, and what is it?
It is actinide series.
Actinoids. Okay.
Actinoid.
Excellent. Okay, you see how to use the periodic table. Are you feeling confident?
Better.
Better. So you guys are, this is like the real slap in the face introductory to chemistry. You need to be able to use the periodic table, right? I don't require you to memorize it, but you should be familiar. You should be able to find where carbon's at. You should know the symbol for carbon, because carbon is a whore, okay? You guys remember that?
Yes, because she's everywhere.
Okay, so you should know nitrogen, you should know oxygen, because those are the ones that you're going to be using most commonly, okay? Now, if you get to the final and you don't know what carbon is, I'm going to guarantee you that I'm going to give you an F almost instantly. You come up to me and say, and I ask you, oh, so what is the symbol for carbon? And you go blank, I'm going to say big fat F. Because at that point, at the end of the semester, you should have it like the back of your hand, right? You should know it, not memorize it. You should know it, okay? Even though you're utilizing the periodic table. You may use the periodic table for a crutch, right? I don't care about that. But I want you to know things, not memorize them, because if you memorize them, what happens?
You're not memorizing the hows and twos.
You're not memorizing the hows and twos, that's true. Also, if you memorize, what happens as soon as you finish this class, you just dump all that shit out, right? I don't want you to dump it out. I want you to continue using it. Everyday life, you should be using chemistry all the time. When you signed up for life. You know, you're going to have a tattoo that says chemistry for life on it.
Okay. If I pass this class, I'll get a tattoo of chemistry for life.
Okay, good. Okay,
Deal?
so let's move on.
And I'll take a picture and show it to you.
Okay.
It'll be on my other hand.
Who was going to say something?
No, I'm done.
You're good? Okay, so we've talked about the groups. We talked about the main groups. You're all familiar with this, okay? So we talked about transitional metals. We talked about metals. We talked about non-metals. We really didn't talk about metalloids too much, but you know where to find them on the periodic table, right?
Yes.
So the thing about metalloids, they have characteristics of metals and non-metals. And so that's going to be kind of important later on when we're starting to form those bonds, because they're going to play that fence a little bit, okay? So can you guys list the atomic number, the chemical symbol, and the atomic mass, or the third period element in group 6A, or 16, group 16.
Third period, 16.
That's going to be
Sulfur?
sulfur.
Okay.
16 mass.
What is its mass?
16.
No, this mass is not 16.
32.00064. They're at old people eyes.
Okay. And its atomic number?
16.
16. Okay. What is its classification?
Non-metals.
I'm not color coded. I don't know.
That's right. It's non-metal. That is correct. Okay. Oops. Okay. So again, these are the most commonly used elements. And so you want to be familiar with these guys and be able to find them, right? But you're going to have your periodic table, so there's no excuse. Okay? Okay, you ready for the next chapter? Chapter 11?
Oh boy.
It'll be fun, don't worry. It's the best one.
Let's do it.
Only gets
I don't think we have
better.
much of a choice.
That's true. That must be Diego, right?
Dr. Henry.
Yes.
Yes.
Are we only supposed to be reading and learning the chapters that you have assigned? Like,
no, if you want to, you can read the whole book. You are more than welcome to it. You're not. So I'm just giving you the order that I'm doing the chapters. So I'm not doing them the way that the book has it designed.
Okay.
I'm doing 2, 3, 5, 11, and then I do 12 and 13, and then I come back and I do 6, 7, 8, 9, 10, and then I do 4 and 14.
Okay.
Yeah, so I like jumping around and keep you on your toes. No, actually, I do it in the sense that makes sense to me, and that where it's easier to understand, because I think sometimes we get ahead of the game before you guys get the foundation. I want you to have the foundation first before you start really playing with the chemicals. Okay? Okay, so let's go to chapter 11. Okay, so I'm going to throw a couple of equations up there. They're going to mean nothing to you right now, but we'll be talking about them along the way, so I want you to kind of remember them. Or actually, we have talked about a couple of them, so I can say they won't mean anything. Okay, so 1, we have E for energy is equal to H nu. Okay, so H stands for Planck's constant.
Is that a VU?
No, it's an H nu.
Okay.
And I'll show you what nu, and nu stands for frequency, like new shoes. So this symbol is the Greek symbol nu.
Okay.
Or Greek letter nu. So it's nu. And that is going to equal to frequency. Don't mistake it for V. Don't mistake it for velocity.
Right, I got it.
Okay.
It's the Greek.
Yeah. Okay. So energy equals Planck's constant nu. And I will actually type up and give you the value of Planck's constant. Planck constant is just it's just an equivalency to allow us to calculate the number of photons that happen in a given interval of frequency. And so by getting that, you can get an idea of how much energy that is being emitted by, let's say, a photon of light or multiple photons of light. Okay? So
can you read those equations again, please? Because I can't really make that out.
That's an E. E equals H nu.
H nu?
H nu, yeah.
Okay.
Where nu equals frequency, and it's pronounced, well, it's pronounced nu, and it's spelled N-U, nu. Okay? H is Planck's constant. Okay? So another equation, E equals mc squared okay? So where C stands for the speed of light, which is given to you down here. You guys see that?
Right.
Okay. M is mass. Okay. So this is Newton's equation. Okay. And we also have E equals 1/2 M, and this is V squared. That's a V. So can you guys distinguish between nu and V?
Yeah.
Okay.
Nu is like a pair of stethoscopes without the bottom part.
Yeah. Yeah. Okay. So V stands for velocity. Okay. You guys got those?
Yep.
So that's how we're going to be able to calculate energy. So if you come across any questions that deal with energy, you want to think about those three equations. If you're given if you're given nu and H, you know that you're going to use Planck's constant. It's just a constant value, right? And then all you need to do is calculate the frequency or half the frequency. We're going to talk about the role that frequency plays in terms of the speed of light, and you know where it plays in terms of energy, right? Questions, concerns, Cash? Excellent. Okay, so you guys have been exposed to electromagnetic waves your entire lives, right? So do you guys, do we have light? Do you have light in your house?
Mm-hmm.
Everybody has light in their house, right?
Yes.
Yes. Okay, good. So that light, is it white light?
Yeah.
Yeah?
Incandescent.
Okay. Incandescent white light, to be specific, okay? So that white light is electromagnetic waves. Do you guys have cell phones?
Yes.
Yes.
Electromagnetic waves. Do you guys listen to the radio? Ooh, yeah.
Yeah.
What is the best song on the radio right now?
I don't know.
Come on, I'm trying to update my playlist here. You're not gonna help me out at all? Gonna keep me in the dark ages? Nobody has the best song on the radio.
Well, I played What Does the Fox Say for my grandson, and he liked it.
What does the fox say? So I have to put that on my playlist. Okay.
Yeah.
What was that, Te Gusta? Did somebody say Te Gusta? Okay, I guess not. Okay, so radio waves, right? Radio waves are also electromagnetic waves. How many of you guys cook? None of you guys, because it's clear. You don't even answer questions. You use the microwave, right? Microwaves are electromagnetic waves, right? So we use electromagnetic waves throughout our entire lives, right? Pretty much now. Can't avoid them. So they exist. So let's try to understand them a little bit. The one thing that you want to know about electromagnetic waves, they're going to be traveling at the speed of light, right? So the things that are going to be different about these waves, the difference between a gamma ray and an X-ray and a UV ray, right? Those, they're going to be different by their wavelength and their frequency. So if we look down here, this here is nu. This is not V. So don't mistake it for V, even though it looks like a V. It's really nu, okay? So it really should be this looking, okay? Nu, okay? This is lambda. You know, like lambda, lambda, lambda. Lambda means wavelength. So wavelength and frequency. So the speed of light is equal to the wavelength times the frequency. The speed of light is a constant. Speed of light always travels the same speed, right? In a vacuum, okay? But it always travels the same speed. So, and that speed is 3.00 times 10 to the 8th meters per second. Or if you want to go to empirical units, want to be back into those chains, we can go with 186,000 miles per hour. I have to think about how to say it. Okay, so that is the speed of light. And so you want to remember it, right? Or at least jot it down somewhere so you'll have it, right? Okay, so we know the speed of light. Now, again, the speed of light is going to be a constant. So the difference between those waves is how big those waves are. Now you guys are going to say waves. You're sitting there thinking about it. Oh, what the hell is he talking about waves? Have you been to the ocean?
Oh God, this kid is something else.
You said God is pissed?
I said this kid is something else. I hired this kid to pick up my backyard and he keeps bugging me.
Okay, so have you been to the ocean? Anybody been to the beach?
Of course I have.
Yes.
Anybody else been to the ocean?
Yes.
So would you guys, I'd assume that most of you guys have at least seen the ocean.
Yes.
Right? So now the ocean has waves, right? Waves of water. Have you guys seen that?
Yeah.
Okay, so waves here are going to be just like that. They're going to be oscillating up and down, up and down, up and down. The wavelength is going to be the distance between two peaks. So let me do my oscillating up and down. Okay, so the distance between two peaks, that is called your wavelength. So wavelength is a distance between those two peaks. Now frequency is how many peaks you're going to have over a given range or a point, right? So if we have this break here, how many peaks will we have that will occur over that break? Okay, so let's say we have this wavelength, and then let's say we have this wavelength. So here, this guy would have a frequency of 3. This guy would have a frequency of 2. Okay, so you'll have 2 peaks in that given range. Okay, you guys see that? Simple?
Sure.
Okay, so now what did I tell you about all of the electromagnetic radiation that you guys experience, from the gamma rays to radio waves? How fast are they traveling?
At the speed of light.
At the speed of light. Okay, so how do they differ? How does gamma rays differ from radio waves? So if they're all traveling the same, how do they differ? Why are gamma rays bad for you? And why can you listen to the radio and go, you know?
Is it the frequency?
It is because of the frequency, right? Because there are going to be changes in frequency, or you can say changes in wavelength, right? Either one of those would have been the correct answer. Or if you're smart, you say them both, because the change in wavelength and frequency. Because that can be constant, the speed of light is going to be constant, but you're changing your wavelength and your frequency between the two, right? One is going to be very, 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 very small in terms of the wavelength, which means that you're going to get a lot more frequencies in that given region. So let's take a look at that. And then we'll do some calculations.
Oh no.
Don't sound too excited.
I'm very
Okay.
excited.
So here, this is basically showing you the electromagnetic spectrum. So this is all of the electromagnetic waves on a given spectrum. So if we take a look, we have our gamma rays, we have our X-rays, we have our UV rays, we have visible spectrum. We have IR, we have microwaves, we have our radio waves, and then we have long wave radio. Okay? So to kind of get perspective in terms of size, we've also put the size of an atom, the size of a virus, the size of a bacteria cell, the size of an animal cell, the thickness of a CD, the width of a CD, and a dog, right? To kind of give you an idea of how far those waves, the wavelengths are for those different waves, okay? You guys can kind of see that, right?
Right.
Yeah.
Yeah.
Good. Okay, so now that you guys are able to see that, let's sit there and talk about it in a little more detail. So here at the bottom is our wavelength. Here's our frequency. If you take a look, our equation says C equals lambda nu, right? Like a new pair of shoes, nu. Okay, so lambda and nu, are they directly proportional or are they indirectly proportional? Let's see, who am I going to pick on? I saw Bernardo kind of creep in. Bernardo, how you doing? Are you there?
Hi, I'm doing good.
You're doing good?
Yeah, how about yourself?
I think you got this. I know, I have faith in you, right? I want you to. So
No, I'm sure, yeah.
My question is, and don't worry, your classmates, they're so talkative today. I've been trying to shut them up. They've just been talking and talking. I'm sure that Aubrey is going to be willing to help you out here in a minute too, right, Aubrey?
Yeah.
Excellent. So with the teamwork, we should be able to get this. Now, is it directly proportional or indirectly proportional? Now, if you can help me out, because we need that definition. So what happens if something is directly proportional? Like if I say your height is directly proportional to your weight.
They're all in the same direction.
They're going in the same direction, right? So as you get taller, you get bigger, right? You get heavier, right? Makes sense, right?
Yes.
Okay, so if it's indirectly proportional, what does that mean?
Opposite direction or different direction?
That's right, opposite direction. So as one gets bigger, the other one gets smaller. Okay, so down here we have our wavelength. Up here we have our frequency. So look at how it's organized. As we go over in terms of the different waves, what's happening to our frequency? Is it getting bigger
Lower.
or is it getting smaller? Getting lower, okay? Now what about our wavelength? 10 to the minus 16, 10 to the minus 14.
It's getting bigger.
It's getting bigger. So is it directly proportional or indirectly proportional to each other?
The frequency and the wavelength?
Yep.
Indirectly.
Indirectly. So our wavelength and frequency are indirectly proportional to each other, right? And that kind of makes sense because we know that the speed of light is constant. Speed of light is never going to change. So as one gets bigger, the other one has to get smaller and vice versa, right?
Okay.
Okay, piece of
Yes.
cake, simple?
Yes.
Yes.
Okay, excellent. Now that we know that it's simple, so what I want you guys to do is, I'm going to tell you. So this here is visible light. Visible light, white light, right, is if we don't diffract it, it becomes white light. All we see is white light because all of the colors are blended together, and all we see is that white light that we light our rooms with that white light. But if we diffract the colors, we get that rainbow, right? This here is called a continuous spectrum. It's called continuous because you don't see like discrete lines of light. It just kind of blends in together, right? Doesn't it look like a painter just went through and they just started painting on a canvas and just kind of blending all the colors beautifully through it, right? Yeah, no, maybe.
Yep.
So that is a continuous spectrum, okay? So that means that you have all of these different wavelengths of light all packaged up in white light, okay? So if I had means to filter out all of the light and I just get the green one, we'll say right here, which will be 525. 525 nanometers. That's the wavelength that I want to look at. Okay, so if I want to calculate the frequency at 525 nanometers, can I do that?
Absolutely.
I heard somebody say absolutely. Yes, absolutely we can. How will we go about doing that?
I have no idea.
Anybody want to help her out? So this is the wavelength. This is my lambda. If I want to calculate nu, how would I do that? Come on, you're getting there. Come on, we can do it. What is this equation above here?
C equals lambda nu.
Okay, what is C?
C is, I don't know.
Ariana, what is C?
C? I'm not sure.
Anybody want to help Ariana and Lorraine out?
Speed of light.
It is the speed of light. Correct.
Oh.
Speed of light. And we know the speed of light is what? What is the speed of light?
186,000 miles per hour.
Don't use the empirical system. Tell me in the metric system.
300 million miles per hour.
That's going to be...
not miles per hour, meters per second.
Hold on.
Okay, so 3.00 times 10 to the 8.
What did I do with that paper? I wrote it down.
Meters per second.
Okay,
Did you hear?
meters.
Lorraine, you're just ignoring your classmates. He just gave you the answer. C equals 3.00 times 10 to the 8.
Correct.
Meters per second.
I see, I wrote it down. I was looking for it.
Okay, so we know what C is, and we know what lambda is. So if I know C and lambda, what do I need to solve? What's left?
For nu.
For nu. Thank you.
So you would just plug it in and divide it over?
So we get nu equals C divided by lambda. Okay, the problem is we have nanometers, we have meters. How do I change my nanometers to meters?
Multiply it by, oh no, not multiply, divide, since it's nanometers to meters.
Okay, I'm going to divide by what?
Divide by 1,000,000, I think.
1,000,000? Are you sure?
Yes.
Okay, let me give you a hint. This is just going to be my only hint that I'm going to give you. Okay, are you ready? Going to listen? You guys ready for the hint? Okay, so what letter starts with an N? I mean, sorry, not what letter. What number starts with an N? From 1 to 10 that start with an N.
9.
9. Okay, so nano is 10 to the 9th power.
Power. Oh, so a billion. A billion. Wouldn't it be?
That's right. It would be a billion. And that's going to equal to 1 meter. Okay. So if we do that, everybody did the math? Did you guys get 5.25 times 10 to the
9th?
Nope.
No.
-7 meters. Okay. We have 10 to the 9th at the bottom here, so that means we're dividing by it, right? So if I divide by an exponent, that means it gets a negative, right? And this is 525. So that's like 5.25 times 10 to the 2, right? 5.25 times 10 to the 2. So if this guy becomes 10 to the -9, and I have 10 to the 2, what is that going to equal?
-7.
-7. So that's how I get my answer. Okay, so this gives me my answers in meters. So now all I have to do is plug this into my equation. So I get 3.00 times 10 to the 8th meters per second. Divided by 5.25 times 10 to the -7 meters. Okay.
So that's going to be 10. And 3 divided by 525. 1 on top goes inside.
Running out of room. All right, too big.
That's 3,000.
Okay, so then what do you guys get for your final answer? How many sig figs should I have? Who wants an A?
I do.
We all
somebody finally answers me.
We're all afraid.
Why? What is there to be afraid of?
Because you might have the wrong answer.
That's okay.
That's how we learn.
Okay, so tell me this. Would you rather get it wrong now, or would you rather get it wrong later?
I'd rather get it wrong now.
Okay. Or would you rather get it wrong here while we're working together, or on the exam when it really counts?
Here while we're working together.
Okay.
Okay, so I put that you divide 5.25 into 3.00, and so you're going to have to move your decimals over. So you're dividing 525 into 3,000 because you're going to add a 0. And I got 106.25. I could be wrong. Is that wrong?
Okay, say what you got again. Hold on.
525 divided into 3,000.
525 divided by 3,000. So you put it on top. The 5.25.
Well, the one on top goes inside the bracket when you divide.
Okay.
That's correct, right?
Yeah,
And then your
so-
-7 from your A is going to just make it 10. So that's got to times that by 10.
Okay. So no. So you should have 3 divided by, so it'll be 3 divided by 5.25, right?
Yeah, can you show me in the brackets like, you know, the old-fashioned division sign?
The old-fashioned division, yes, sure. It would be 3.00
Oh. So the 5 goes
divided
inside.
by,
No, the kind that goes up and then across. You know, up like a upside down L. Long L.
I see what you're saying, yes. The old-fashioned sign. Okay.
Right. There you go. So I did do it right.
Yep. Okay, so what did you get?
I got 106.25, but I know that's wrong
Okay.
because the 25 should go into the 3,000, actually 525. So
Okay. What did you get? Anybody else get an answer?
I tried.
No, that's all we can do. We can try, right? That's what I'm here. We're here to help you figure it out.
Maybe I should use my calculator.
That would help. Anybody use their calculator? Okay, that's fine. I'm done for today then. I'll see you guys later. Peace.
No, I want the answer.
No, it's too late. Y'all don't want to play.
I
Nobody
did
wants to
play.
This is
I did
an
play. I
interactive.
told you what I got.
Okay. This is for you, Lorraine. I'm going to share with you only. Are you ready? I'm going to give you the answer.
Yes, sir.
Okay, so I'm sending it to you. The rest of you guys, y'all don't want to play? We can play that way. Let's see. Let me find you, Lorraine. Let's see.
I'm the pretty old lady.
Okay, see, that's all you have to say.
PYOT.
There we go.
Pretty old thing.
Gotcha. Okay, so you're gonna get. Now the caret, that thing that goes up and down, that's just gonna be the exponent for that, okay?
Okay.
Okay, so that's caret. Where's my caret?
Thank you. Is it going to be on this screen or in my email?
No, it's going to go to your chat window.
Okay, there it goes.
And for the rest of you guys, since you don't want to play fair, fine. Oh, and the units are, don't forget the units, it's going to be hertz. Because it hurts so good, which is the same thing as 1/seconds.
So it's hertz.
Yep.
Lorraine, you mind forwarding that after this conversation?
Charge them $5 because I guarantee you there will be 2 questions on the exam that are going to have this now because you guys didn't want to play. Fine then, I'll teach you.
Thanks, Dr. Henry.
No problem.
Now get off the phone so I can tell everybody.
Nope.
Okay, HZ, okay, or 1. Okay. I got it. Okay, I won't do it.
So I need to go. You may be able to bribe some of the tutors to help you out with this, but I guarantee you now there are going to be at least 2 questions, and one of them is going to be hella hard now. You made me mad.